Hello. In this way, in the previous video, I almost ran out of going into the example. You see that I had to stop this thing before 15 minutes is over. Okay. So anyway, so here, okay. So this is what we did. Okay, the hypothesis testing and the confidence interval. Okay. So here, if you have a kind of large sample, this is what you want to use. For a small sample, you may want to use that. Okay, this is not good for if you are dealing with a small sample. But if you have large sample, they almost both will come out the same. Okay. All right. So let us look at an example. So for hypothesis testing as well as the confidence interval. Okay. All right. So here, this is a very simple example. So you have two things. You want to compare these two rates. So basically, can we conclude from this data that the sample population, there is a difference in the proportions who are overweight. So you want to compare male versus female, the rates. Okay. So is there a difference? So you are dealing with two-tailed test. Is there a difference? Okay. So you want to test the null hypothesis P1 equal to P2, either that or P1 minus P2 equals 0 and not equal to. All right. So here, so the P tilde thing. Okay, so here, because you're going to calculate under the null hypothesis, you have the same thing. P1 is same as P2. So you're going to get a common estimate. Okay, so the common estimate, which is the P tilde, is going to be the number of S's in the first sample, which is 21, the number of S's in the second sample, 48, divided by the total number of the sample, the number of trials in the first sample, which is 150, and then the sample size for the second sample 200. Okay, so is that P tilde is that, so this is going to be that. So the Q tilde is going to be 1 minus this value, which is that. So then, so the sample Z, so the sample Z is going to be that right there. Okay, so the P1 hat is coming from the sample proportion for the first sample, this one. Okay, P1 hat, see that P1 hat is the sample proportion for the first sample. So which is going to be, P1 hat is going to be 21 divided by 150, which is 0.14. So the Q1 hat is going to be 1 minus that, which is that. So the P2 hat, the proportion for the second sample, 48 divided by 200, which is 0.24. So Q2 hat is going to be 0.76. All right. So once you have these, so these two values, this and that, will go into this P1 hat, P2 hat, coming out of that. Okay. So the 0 that is coming out of, see, P1 minus P2. So really you are trying to see P1 minus P2 equal to 0. The way we put that thing right there. Okay, this. So if you are trying to see something else, that value, the number has to go over there, right there. Okay, so that is 0 you are trying to see. And so this, the part in here is that the P tilde, Q tilde, like that. So if you wanted to, you can, this part is the common piece. Okay, you can take common value out and put that N1 and N2, because this part is same as that, this part. Okay, so that's the way I wrote this part. Okay, the P tilde, Q tilde, that 1 over N1 plus 1 over N2. In other words, I took this common piece out inside the square root sign, this part, okay? So that. So here that, so calculate that, this is your sample Z, so which is going to be minus 2.3273. Alright, so now we are going to compare against the Z table value. So the given alpha level 0.05, so this is a two-tailed test. You know the cutoff for that 0.05, which is sitting at minus 1.96 and plus 1.96. The value I told you to, you may want to memorize coming out of the Z. Okay, so that, so here this value is inside. So either this side or this side you reject the null and accept the alternative. So here your conclusion is you reject the null and accept the alternative at this level. In different words, the test is significant at 0.05 level. Okay? Alright, so now if you want to find the p-value or the observed significance level, so what you do is that you set your cutoff right on that value, which is minus 2.33, because I rounded this value to the nearest second decimal point because you have to read the Z table. So because of that I round it. So, so here and the Z table, you need to get these two shaded areas. Again, this is a two-tailed test. So there are two rejection regions. So you need to multiply by 2 and get that area. So that area 0.0099. So times 2, that is going to be this. So this value is coming out of the Z table. Okay, so the p-value is 0.0198. If nobody gives you the alpha level, so you make your conclusion like this way, the same way we did before. If your alpha level is bigger than this p-value, you reject the null and accept the alternative. Otherwise, you cannot reject the null hypothesis. Okay, so when you figure out the confidence interval, so here, by the way, these both are kind of big samples. So the both conditions, like the conditions I gave you before, that the both methods. So this one, the number of S's and number of F's in both samples must be at least 10. So that is correct actually. See right there. So these are the number of S's. So the number of failures is going to be 150 minus 21. So both are, of course, going to be more than 10 or 15, okay? So both conditions are good, actually. The same thing over there. Okay, so therefore, if you wanted to, you can use the method 1 or method 2 because the sample size are quite big anyway. Okay, so anyway, I calculated both so that way you can check out, okay? So here, what you do is that, so this part, so it's going to be, so P1 hat, which is that, P2 hat, this one, and this value is coming out of, if you are dealing with a 95% confidence interval, 1.96 coming out of the Z table, the square root, this P1 hat, Q1 hat divided by the sample size N1, P2 hat, Q2 hat divided by N2, which is 200, okay? So the same thing, upper limit is going to be the plus sign right there. So then you calculate that. This is your 95% confidence interval. This is pretty good actually because this condition, what we said is correct. Okay, so it's sample size, they are pretty big, so that is correct. Okay, so this got to be correct. The minimum must be 10. Most books, as I said before, must be 15. Okay, all right. So suppose if you want to check this one, so but you have to figure out P1 tilde, P2 tilde, P1 tilde, Q1 tilde using this formula. Okay, but this is very important if you are dealing with a very small sample. Don't use that. Okay, this is wrong actually if you use that for small sample. See, remember that here N1 is 5, more than 5, 5 or more, N2 is more than 5 or 2. See, these are humongous, okay, compared to that. So there's no issue with this method, okay, the first method. So if you have a small sample, this is what you got to use. So here if you use that, you can see that, all you have to do is that figure out that P1 tilde hat. So the reason I did that one, so that way you can look at what I'm doing, okay. So then you are looking at the number of S's, which is 21 plus 1. So the number of sample size 150 plus 2, okay. So that is that. So Q2 tilde 1 minus that, which is that. So P2 tilde is going to be 41 plus 1 divided by 200 plus 2. So which is that. So Q2 tilde is going to be 1 minus that. So then you use the same formula, okay. So P1 tilde, this value, P2 tilde, this value. So this value again coming from the Z table, the same as that before. And inside the square root, so P1 tilde, Q1 tilde divided by N1 plus P2 tilde, this one, P2 tilde, Q2 tilde divided by N2. Alright, and the upper limit of that interval is going to be the plus sign right there, okay. So you calculate that and evaluate it, okay. So they are very close anyway, they're quite big samples. See, what happened is that when n is big, this part is almost negligible. If you are dealing with a big number, this part is almost negligible. So this is what we use in the first one, right there. Okay, see, right there. See, that's why I said that it's going to be negligible, almost the same for large n anyway, okay. But for small n, this does matter, okay. All right, so anyway, this is how you compare two proportions, all right. So if you want to compare something else, say if you want to check some other number, in most cases we are going to deal with 0 or not 0 or greater than 0 like that, okay, or less than 0. But some other number, that number goes in there. Alright, so we are done with that, comparing two proportions.